we're going to talk about the work done by the force of gravity and make conclusions about what conservative forces are all about. Alright, to discuss the work done by the force of gravity, let's displace an object from the ground to a given height, or vice versa. So in this case here, I'm using the initial to be the ground and final to be here. The path in which the object is moved is not necessarily known, but we know what the initial point is and what the final point is. Since the mg is a constant quantity within a reasonable height, therefore the work done by the force of gravity is going to be expressed by the following equation. The work done by mg equals, the mg is a constant force times the displacement d cosine the angle that the mg makes with the displacement. We all know that the mg points straight down, like this. The displacement is the shortest distance from the initial point to the final point, which would be a straight line from I to F. That is the displacement. Alright, notice that the angle that the mg makes with the displacement is 180 degrees, because the mg points down and the displacement points up. This angle right here, this is 180. Substituting what is known, we find the work done by mg equals mg times the displacement. The displacement d can be expressed in terms of heights. Let's say the height initial is the bottom right here, and the height final is right here. The d would be h final minus h initial, cosine 180. Keep working on this. Here is mj, here is the height final minus initial, and we all know that cosine 180 is -1. Bring the negative to the front of the equation, you would get the work done by mg equals negative mg, distribute mg, we get mg h final minus mg h initial. This expression mgh is very familiar, which is the potential energy. Therefore, the work done by mg equals negative Pe final minus Pe initial. This can also be written down like negative delta Pe. All forces that behave the same way like the force of gravity, where the work done only depends upon the final position and the initial position, are known as conservative forces. Conservative forces are those forces where the work done by them does not depend upon the path taken, it only depends upon the initial position and the final position. Work done by conservative forces equal negative delta Pa. This Pa is not necessarily the gravitational potential. It could be something else. It depends upon the force.